Acceleration is an idea that most people have a general concept of, but they don't know how to put numbers on it. I mean, if you say accelerate, you get the idea of going faster. Or in English, we would say decelerate if you say slam on the brakes. To a physicist, that's just acceleration with a minus sign. So speed up and slow down are both acceleration. But there's something else that is also acceleration, throw some people, if you turn. So if you hit the gas, hit the brake, or turn the wheel, any of those are acceleration. Here's a tip. If you were riding as the passenger in a car with your eyes closed, acceleration is what you can feel. If they slam on the gas, you feel yourself push backwards. If they slam on the brakes, you feel yourself push forward. If they turn sharply, you feel yourself leaning sideways. You can feel acceleration. So yes, turning does count as acceleration. But how do we put numbers on it? Let's suppose we have an object and we're tracking it from 0 seconds to 5 seconds. And every second we're going to measure how fast it's going, its velocity. Let's say for direction purposes it's just always moving in the positive x direction. So really all I care about is the speed. So let's say that right at the beginning, if you looked at it, it was already moving at 10 meters per second. And a second later, it was going at 13 meters per second. And a second after that, it was going at 16 meters per second. And then 19 meters per second. And then 22 meters per second. And then 25 meters per second. What is that doing? How can we sum that up? It went up 3 meters per second. And it's doing that every second. 3 meters per second. Per second. We like to simplify fractions, so we would write that as 3 meter per second squared. But that's what it really means. The velocity is changing. And a constant acceleration means this is a constant rate of change. It's always going up 3 meters per second. So acceleration is the rate of change of velocity. And this is how we put a number on it. The basic formula for average acceleration is change in velocity over change in time. Because the acceleration is constant in this example, acceleration at any moment is the same thing as the average. So all we have to do is say, how much did the velocity change, and how much did the time change, and divide. And meters per second divided by second gives you meter per second squared. That's what acceleration is. There's also radial acceleration, or centripetal acceleration is another name for it. Generally, it's the turning kind of acceleration that I mentioned. How are we going to put numbers on that? It turns out there's a very simple formula for it, that the acceleration in the radial direction is your speed squared divided by the radius of the turn you're going around. So if a car is turning through 40-meter radius circle and is traveling at 10 meters per second, it would have an acceleration of 10 meters per second squared over 40 meters. That's 100 over 40, 2.5 meter per second squared. Meter squared and a meter cancel. Second squared goes on the bottom. So that is how you would put a number on how sharply you're turning. And the sharper the turn, the greater the acceleration. That's how you put a number on radial acceleration. I hope this clarified the concept.